So if you're a maker, you almost certainly started out with the good old Arduino Uno. It's a legend for a reason. But after you've blinked all the LEDs and spun all the motors, you start to hit a wall. You're thinking, what's next? You want more speed, more memory, maybe some wireless action. It's a classic moment for anyone in the electronics hobby. And this question right here, pulled straight from a Reddit thread, it just hits the nail on the head. You're ready to level up, and you've got your eye on the Raspberry Pi Pico W. But how big of a jump is it, really? Is it a small step or a giant leap? Well, let's get into it. All right, so in one corner, we've got the Arduino Uno, the undisputed champion, the veteran that taught so many of us the ropes. And in the other corner, we have the Raspberry Pi Pico W, the lean, mean, powerful newcomer that's been making some serious waves. And just look at him. You can see the difference right away. The Uno is big, friendly, almost iconic. You can see all the parts clearly laid out. Then there's the Pico W. It's tiny, it's dense, it's built for a world where every millimeter counts. But the real story, the stuff that's going to change how you build things, well, that's all under the hood. Okay, just look at these numbers. This isn't just an upgrade, it's a whole new league. The Pico's clock is over 8 times faster. It has more than 130 times the SRAM, that's your active working memory, and 64 times the flash storage for your code. Oh, and did I mention it has 2 processor cores? Plus built-in Wi-Fi and Bluetooth? Yeah, it's a completely different beast. But, and this is a big but, all that new power comes with a few new rules. You can't just swap one for the other and expect everything to work. There are 3 big hurdles you're going to have to clear first. First off, you gotta tame all that new power. The Pico has 2 cores, which means it can literally do 2 things at the exact same time. Now that's awesome. It's like having 2 chefs in the kitchen. But you, the programmer, have to be the head chef. You have to make sure they don't crash into each other trying to grab the same data at the same time. It's a new concept called synchronization, and it's something you just don't worry about on the Uno. Hurdle number 2, how are you going to talk to this thing? With the Arduino, it's pretty simple. You use the Arduino language, which is based on C++. But the Pico, well, it gives you options. So you can stick with what you know, C++. That's going to give you the absolute best performance, total control over the hardware, just like on the Arduino. Or you could try MicroPython. It's way easier to learn, the code is cleaner, and you can get things up and running super fast. The catch? It might run a little slower, and it kind of hides some of the nitty-gritty details from you, which might be a good thing or a bad thing, depending on what you're trying to learn. Okay, now for hurdle number 3, and please listen up because this is the most important one. This is the one that can literally let the magic smoke out of your shiny new Pico if you're not paying attention. It all comes down to voltage. Here's the deal, and it's simple. The Arduino Uno and most of the classic shields and sensors you probably have for it, they all run on 5 volts. The Raspberry Pi Pico, on the other hand, runs on 3.3 volts, and, this is the critical part, its pins are not 5-volt tolerant. You feed a 5-volt signal into a Pico pin, and you are going to have a very bad day. I mean, you can't get much clearer than this. The advice from the community is blunt for a reason. Don't do it. Don't take that 5-volt sensor from your Arduino kit and plug it straight into your Pico. You will very likely fry that pin, or maybe even the whole board. But hey, don't panic. There's a super simple, super cheap fix for this. It's called a logic level shifter. Think of this little guy as a translator. It sits between your 5-volt device and your 3.3-volt Pico and makes sure they can talk to each other safely without anyone getting hurt. And setting one up is a piece of cake. You just give it both voltages, 5 volts on the high voltage side, 3.3 volts from the Pico on the low voltage side. Connect the grounds together. Then you just pass your signals through. The 5-volt signal goes into a high-voltage channel, and it pops out the other side as a safe 3.3-volt signal on the low-voltage channel. It's that easy. Okay, so we've jumped the hurdles, we know what to watch out for. Now for the fun part, the reward. Why would you go through all this trouble? The answer is one of the coolest features in the microcontroller world right now, something called Programmable I/O, or PIO. So what on earth is PIO? Well, basically, it lets you create your own custom hardware in software. I know, that sounds weird. Think of it like this. You've got some weird old sensor that needs a very specific, very fast timing signal to work. Your main processor is too busy to handle that perfectly. With PIO, you can write a tiny program that turns a piece of the chip into a dedicated little machine that does nothing but talk to that sensor perfectly, freeing up the main cores to do the heavy lifting. And this right here is a perfect example of PIO in action. Trying to generate a VGA video signal on an Arduino Uno?
Forget about it. The timing is just too fast, too precise. It would completely take over the processor. But with the Pico's PIO, you can offload that entire task to its own little state machine. It's what lets a tiny, cheap microcontroller do things that used to require much more powerful hardware.
So what does this unlock for you? It means you can drive massive arrays of neopixels with flawless timing. You can talk to weird, non-standard electronics. You can even generate your own audio and video signals. You can finally take on those really ambitious projects that your Uno just couldn't handle.
So, with all that on the table, we come back to the big question. How do you choose? Which board is the right tool for the job you have in mind?
Here's the bottom line. Stick with the classic Arduino Uno if you're just learning the ropes, if your project is simple and uses standard 5-volt parts, or if you just need super reliable, no-fuss control of a few servos. But it's time to move up to the Raspberry Pi Pico W when your project starts getting hungry for more memory and speed, if you want to write your code in Python, or if you need Wi-Fi. And of course, if you want to dive into that incredible world of custom hardware with PIO, the Pico is the way to go.
Oh, and one last thing. The community brought up another board you should definitely know about, the ESP32. You can kind of think of it as another great step-up option with tons of power and amazing connectivity. It's a real powerhouse in its own right, so it's absolutely worth checking out as well.
In the end, moving from the Uno to the Pico isn't just a simple component swap. It's a real expansion of what's possible for you as a maker. Sure, there's a bit of a learning curve, but the payoff is huge. You get so much more power, so many more possibilities. So the only question left is, what are you going to build?